Hi students, today we are dealing with Newton's laws of motion or laws of motion. When you talk about laws of motion, mainly Newton comes into our mind, right? Newton comes into our mind. So in this video, sorry, we are going to study what is force, okay? What are the different types of forces? What are the different types of forces? And then what are Newton's laws of motion? Newton's laws, NLM, Newton's laws of motion. And the third one is free body diagram, free body diagrams. And depending upon this free body diagram, okay, how this body diagram related to the numericals we observe. Okay, and Newton's laws, after Newton's laws of motion, what are its applications where these can be generally used? All these things we are going to study in this video. Okay, let us start with force. What is a force? A force is a push or pull which changes or tends to change the state of rest, tends to change the state of rest or of uniform motion or direction of motion of any object. Say from rest to motion it changes, or from uniform motion to rest, uniform motion to rest, it is going to change. For example, you take how the rest and motion, how it changes. Say a toy, a ball is at rest at the beginning. If you apply something, if you apply some pressure on it, so it tends to move like this, right? So it changes its state from rest to motion, right? So it is going to change from rest to motion. When you apply brakes to a vehicle which is moving, that is in uniform motion at the beginning, right? So if it is in uniform motion, when you apply brakes, it comes to rest. That is also by the application of some pressure. So what is that? Some push or pull we are applying. That is nothing but the force. So finally, what is a force? A force is a push or pull. What is that? Either push or pull. You can do both. Okay, any one of them. Push or pull, which changes or tends to change the state of rest of uniform motion or direction of motion of the object also. Sometimes if you open the door, you are opening the door, right? So what are you doing? Just you are applying the pressure and you are changing the direction of motion of your door, right? So like this, these are the general examples we can observe about how the force is going to make in the real life, real daily life. Okay, so force is the, in here we are observing, you are observing the ball is object, right? Here ball is our object. Okay, so and which is the source? Say your hand or your leg. So leg is the source. So what you are doing? So you are providing, you are giving some pressure with your leg onto the object. This is the source. This is giving some pressure, some push or pull onto this object, right? So force is the, it is no doubt when the leg is in interact with ball, when when leg interacts with ball, then we are getting a motion of the ball takes place. The ball is going to move, right? The ball is going to move. That means the force is the interaction between object and source, right? Force is the interaction between object and source, sorry. So no doubt you are saying that if you apply a force, the ball is moving in this direction, right? In a particular direction it moves, depending upon the force. Okay, yeah. Now we can say that we are specific with the direction. So when you specify with direction, that can be called as what kind of quantities? Yeah, vector quantity. Very good. Vector quantity. So we know, no doubt you are applying some very less pressure. So less. if you apply less pressure on the ball, it moves a small short distance, right? If you apply more pressure, the ball is going to move very more distance, right? In the so that is you are saying less and more. That is nothing but our magnitude, right? So if you talk about only magnitude, that can be called as, what is that physical quantity called? Yes, very good. Scalar vector. Okay, sorry, scalar quantity. And when you talk about direction, in addition to this magnitude, this can be called as vector quantity. So here we are observing the direction. No doubt we are observing the direction. So we can say that this is a vector quantity. Okay. So what are the three things we observed? Depending in the force is nothing but it is a push or pull which tends to change from rest to motion or uniform motion to rest. Okay. uh, and the second one is force is the interaction. It is the interaction between object and source. It is the interaction between object and source. Okay. No doubt it is a vector quantity because it depends upon the, it changes its direction depending upon the application of the pressure. Okay. Got it. So what are the SI units of force? You already studied about the SI unit of force is Newton, right? So on his name only we got different laws under the motion. Those are called Newton's laws of motion. Okay, we will study in detail in the next coming classes. Okay. Now CGS unit of force. What is the CGS? This is SI or MKS. Okay. SI or MKS unit of MKS unit of force is Newton. And what about the CGS unit? The CGS unit of motion force is dynes. What is that? Dynes. Okay, dyne is the CGS unit of force. Newton is the SI or MKS unit of force. Okay, what about FPS unit of force? The FPS unit of force is pound. FPS unit of force is pound. Got it? So these are the system and their units of force. Okay. So we studied about the total force. Right. Now, we no doubt we got the definition what the force is doing. Actually, what the force is doing. What a force can do. What a force can do. Let us observe. So when you apply a force, what happens? If you apply a force on the ball, what happens? It changes its speed, right? So it is going to change its speed. Yes, it changes its speed, right? Very good. And what about the next point? So is it changes direction of motion also? Yes. Say, if you kick a ball from this end, what happens? If you kick a ball from this edge, the ball is going to move in this like this, right? So it stays here. When you kick a ball straight, how it moves? So it is going like this in straight wise, right? It is going straight like this. Yes. When you kick a ball like this, so it is going to move in this, not exactly in the opposite direction, I can say. Just that is the generally it moves. Yes. So if you kick a ball, it goes somewhat straight and then somewhat after moving straight, depending upon the force, it is going to change its direction, right? So what I'm saying is just it changes its speed and it changes its direction of motion also, right? It changes its direction of motion. Okay. It changes its direction of motion. And both speed and direction of motion. Not only it changes only speed here. If you kick a ball, it changes not only changes its speed, right? It changes its direction of motion also. Sometimes both direction of motion and direction of both speed and direction of motion also. Okay. And sometimes it changes its size and shape. Yes, size and shape. You observe, you think of some examples. It changes its size and shape. Say, let us take any kind of clay. I am taking clay. Okay. So that I am taking a big clay. Okay. I am taking somewhat this kind of clay. If I press it, so it changes its size to small, right? It changes its size to somewhat small when compared to the previous one, right? So, and then you can observe the shape also by observing this clay. Okay, first I took a round clay. Then what I am doing, just I am making this total clay in the form of a triangle. Yes, I can do it, right? So in the form of a square. Some children, they can play different pictures like triangle, rectangle, yes, and then square. All the things they are going to make with the clay, and they are going to play. They are going to make like some any kind of smileys, all those things. So different shapes they can make, even though it is a circular clay or any no shape clay also, right? There is no shape for the clay. If you take clay, just then there is no shape at all. So if we are converting that shape, that is, it is going to change the shape and size. If you apply a pressure, you are applying a pressure on the clay. Because of the application of pressure, it changes its size and as well as shape. So these are the things force can do. What are the things force can do? Force can do by it changes its speed. Yes, it changes its speed, and then the direction of motion, and both, and it changes its size and shape. Got it? Yes. Now, if you observe the fundamental forces. What are the fundamental forces? The fundamental forces are those which are basic. Fundamental means basics, right? Basic thing. So fundamental forces. All the forces, what are those? Fundamental forces. What are fundamental forces? If you observe the forces which are in nature, like muscular force, yes, muscular force. So by means of muscle, you are applying some force, yes. And then free elastic. By if you take elastic, if you expand it with your hands, with the two hands, what happens? It is going to expand, right? It is going to it shows the property of elasticity, right? So elastic in nature, elastic, and then weight and magnetic. You observe magnet also, it experiences some force, right? Nuclear forces. Yes, if you take an atom consists of nucleus, right? At center. And electrons are revolving around the nucleus in a particular orbits, right? So, whereas protons and neutrons are the subatomic particles which are present inside the nucleus, yes, and electrons are revolving around the nucleus in a particular or well-defined orbits, right? Okay, if you observe the force of interaction between the two masses, let us take, I am taking the two things which are having masses m1 and m2. Okay, m1 and m2, the two particles which are having masses m1 and m2, they are separated by a certain distance. Okay, and you take the position vector r. Okay, certain distance r. Okay, the force of interaction between these two point particles m1 and m2, due to some due to their masses is called gravitational forces. What are gravitational force? Gravitational force is the force due to the interaction between two point particles which are having some masses or separated by a certain distance, or because of these two particles there exists some force, that is called gravitational force. Say I am taking this particle, this is the source. Okay, I am taking this is the source. Okay, and this one is the position vector or test particle. I am taking this as test particle. Okay, this is test particle. S is the source I am taking. Okay, test particle S and T both are separated by a distance R. Okay, the position vector R. If you observe the force which is existing between these two masses can be given by, no doubt force is also a vector quantity, right? Because it has direction. Yes, force has direction, because what force can do in that we observed, it is going to change the direction, right? Yeah. So F bar is equal to minus G times M1 M2 pi R cube in times position vector R. This is the expression which is given by force. So here R is the position vector of test particle, where you located the test particle from source. That is position vector of test particle. What is our test particle? That is T, okay, with respect to the source, okay. And G is the gravitational constant. What is G? G is the gravitational constant, that is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Okay, per kg square. This is the unit of gravitational constant. You know how to get a unit for any quantity means just by writing the formula and writing the units of each and every quantity, and you make that quantity as the subject, so that you can get easily the units of any kind of quantity. But one thing, what is the condition? You should know the formula. If you know the formula, then you can easily get the units of any particular quantity. Okay, very good. So you observe this gravitational force. What kind of force? So we are saying that, yeah, some forces are acting. So some forces are strong and some forces are weak, right? So this is the weakest force. We can say gravitational force is the weakest force. What kind of force it is? It is weakest force. It is weakest force and is always attractive. It should always be attractive. Yes, it never repel. It is always attractive. Okay. It is the long range of force, and it is going to act, just we observed, between two particles, right? Situated at a certain distance in the universe. So you take any particle, those two are separated at a certain distance. So no doubt, between any two particles there exists a gravitational force. Gravitational force. Yes, there exists gravitational force. So you observe here, you are taking the two particles. Okay, say there should be two particles are separated by, no doubt there should be some medium, right? Yes, medium. Medium means either, so the first particle and the second particle, what should exist? That can be called as medium, right? So that medium, either it may be a solid, liquid, or gas, right? So these are the things may be media, right? So if whatever may be the medium, it is always independent of medium. Okay, the two particles, it is independent of nature of medium between the two particles, either a solid, liquid, or gas, whatever it may be. So it exists, gravitational field exists, so that nature is somewhat, it is the weakest force and it is always attractive. So the properties of these never change, whatever may be the medium. Okay, so gravitational force is the force which is weakest force, and it is attractive force. Okay, and it is independent of the medium. Okay, these are the things you have to remember when we talk about gravitational force. Let us move to the electromagnetic force. What is that? Electromagnetic force. You observe The name itself says magnetic. Yes. So before case we observed gravitational force is always attractive force, right? G is always attractive force. Whereas electromagnetic force, it may be either attraction or repulsive, right? Either it may be attractive or repulsive, right? So force exerted by one particle on the other side, on the other, because of some electric charge particles. Because of what? Electric charge on the particles. Electric charge. Electric charge on the particles is called electromagnetic force. How do you define? Force exerted by one particle on other. Say this is 1 and 2. Force exerted by one particle on other. So the force is exerting on this particle. How this kind of force is exerting? Because of electric charge on the particles. So there is some electric charge on this particle and as well as on this. Due to this, due to the charge present between the present in the particles, this electromagnetic force exists at that particular place. Okay, this electromagnetic this is electromagnetic force. I told already because it is a no doubt it is a magnet. Magnet means we have either attractive or repulsive, right? So there are two kinds of forces exist in this electromagnetic force. Understood? So if you compare this electromagnetic force with that of a gravitational force, the gravitational force is weakest, but it is not that much weak. Okay. So, and also it is attractive, it is either attractive or repulsive. That is totally attractive. Understood? And attractions, then main electromagnetic attractions and repulsions between atoms or molecules. This is the most important thing we observed in chemistry. Mostly this can be either attractions or repulsions between molecules or atoms. Okay, got it? Next, we go to the next force. What is that force? Nuclear. Nuclear force. The name itself suggests. What it suggests? The nuclear force, it is very strong. And also we can say strongest. It is the strongest force. Okay, it is the strongest force. It keeps. So we know what is an atom. What are the subatomic particles which are present in an atom? We know. Yes, electrons, right? And center there is a nucleus, right? The nucleus contains, what are the things it contains? Protons and neutrons, right? So protons are positively charged and neutrons are neutrally charged and electrons are negatively charged. P positive, you can remember. PP, don't confuse. Positively charged particles. PP, like that you can remember. Protons positive, okay? Neutrons neutral, nil. Yes, neutrons neutral, neutral. There is no charge. No, NO, no. Yes, neutron no charge. Electrons are negatively charged particle. Okay, like this you can easily remember. And now, this is the strongest force. It keeps the nucleons together. You know, protons and neutrons are present inside the nucleus, right? So, inside the nucleus. So, even though, in spite of this, what do you say? Large electric repulsion between protons. I said protons and neutrons both are present here, right? So you have protons no? Inside the this is take nucleus. I am taking this as a nucleus. Now here it contains protons, right? So protons, if you observe the protons in between the two protons, because both are positively charged, yes. So there should be repulsion. You know the charge law of conservation of charges. What is that? Like charges, like charges, like charges repel. Okay. And unlike charges attract. Okay. Here you observe proton and proton. No doubt each proton is having positive charge. So both are positive. When both are positive, there is a repulsion exists between them, right? So repulsion, even though those are repelled together, when they repel, what happens? They should move away, right? But this kind of nuclear force keeps these two protons together. Got it? So nuclear force, the force, how it is going to be. So we have many things, and also this can be because of this unbalancing of nuclear forces, nuclear forces. We can make the protons together just by means of radioactivity, fission, and fusion. These are the techniques. So because of these are the different processes. Because of that, these protons together inside the nucleus. Okay. So what happens? It acts within the nucleus that two up to a very small distance. This makes these two protons together. That means they are very close together inside the nucleus itself. So which force keeps the nuclear force? So it is the strongest force. It keeps the nucleons. What are nucleons? What are nucleons? Nucleons. Nucleons contain protons and neutrons. The protons and neutrons, because these two are present in nucleus, that's why we call nucleons. Got it? Yes, very good. Next, if you go for, so I am I think it is crystal clear nuclear force, right? So nuclear force is the force which is strongest one. So which, for example, it keeps the protons and neutrons inside the nucleus together, and not only neutrons, protons inside, because of repulsion, they may not go away. It keeps the repulsion between them. The repulsion, it controls the repulsion between them and keep them together. Okay, got it? Yes, very good. Yes, let us move to the next force. If you observe the weak force, what is the weak force? Weak force. It acts between any particles, any two small elementary particles under the action of a neutron. Under the action of a neutron. It can change into a proton. So under the action of a neutron, when it acts under the neutron, what happens? It changes into a proton. What happens? A neutron converted into a proton, it emits an electron. It emits an electron. It emits an electron and a particle. So whatever the new particle we are getting, right? So what happens? It behaves always. It acts between two particles, not elementary particles, means any kind of small particles. Under this action, a neutron can change into a proton. What we are doing? A neutron can be converted into a proton by emitting an electron. So whatever the new particle can be called as anti-neutrino. What is that? Anti-neutrino. Why it is called anti-neutrino? Because it is opposite to the neutron, right? By taking neutron is changing, neutron is converting proton, and it is emitting an electron, right? Anti-neutrino, this can be called as. So this range of force is somewhat small. The range of force is somewhat small, and because this is neutron, no? So it will be very small, we can say. Very small. the size of the proton, if you observe, so if you observe the range of this one is very small. Why? Because the size of the proton and the size of neutron are very small, right? Size of proton, size of proton or neutron, those are very small, right? So we can say that the it has been found that this force starts acting for two protons. This kind of force generally act between two protons. Two protons at a distance of 1 Fermi. 1 Fermi. Okay. These two are separated by a distance Fermi. The atomic distance generally measured in Fermi. Okay. Fermi, the unit. Understood? So weak force, when you talk about uh, weak force that is anti-neutrino particle comes into the picture. Got it? So two protons separated at a distance 1 Fermi, we can observe this kind of force, this kind of weak force, or you can observe when two particles, two elementary particles, when they are under the neutron, they are one particle under neutron. What happens? It it converts into a proton and it emits an electron. Okay. Under its action, a neutron can change into a proton and emitting an electron. Whatever the particle, with the changed particle can be called as an anti-neutrino. Okay, and it is very small when compared to the size of the proton and neutron, also very small. So the size is too small and this force is very small. Okay, got it? And one kind of force, this kind of weak force exists in this case also, that is two protons when separated by a 1 Fermi distance. Fermi is the atomic distance can be measured in Fermi. Correct? Yes. Now we classify the forces on the basis of contact. You see, I am saying there is an apple falling, apple falling from a tree, right? So apple is falling from a tree onto the ground. That means which force? Apple is here and ground is here, right? Earth is here. So is there any contact between them? No, there is no contact, right? So it is falling, right? Yes, very good. Now, if you take a magnet, this is a magnet, okay? What I am doing, I am taking a small nail, okay? I am keeping nail near to magnet. What happens? So the magnet is going to attract the nail, right? If it attracts the nails, that means whenever whenever it is in contact, that means it is very near, very near. If it is very near, or when it is in contact, the force is existing, and the force, because of that force, the result is going to happen here. But here there is no contact between earth and the apple, but this there exists gravitation here, right? Yes. That means here we can decide this is contact force and this is non-contact force, right? So forces can be classified as two kinds, okay? Non-contact. What are those? Non-contact. Non non-contact non-contact force, and the second one is contact force. Okay. Yes, very good. Non-contact force. That means here there is some field. Okay, there is some field exists. That is gravitational field is existing here, right? Because of the gravitational field, the whatever the apple which is attracted towards the earth and it is falling on it, right? Yes, very good. Now, the contact force. This force which makes non-contact force. Let us talk first non-contact force. This this force between, say, I am taking two bodies. Okay, two bodies are separated by a some short range of distance. Okay, some short distance. Now, what happens when separated by a short distance? Even though they are separated by a short distance, there is no contact between them, but this is going to attract this, right? So that means we can say there is some field existing between them. There is some field. So that's why this non-contact force can be called as field force. Okay, field force. Now this is, for example, you take gravitational force as said the example that the apple and earth example. So gravitational force. Yes, gravitational force we studied at the beginning. Gravitational force. Okay, gravitational force is which is the weak force, right? Weakest force. And if you observe electromagnetic also, electromagnetic force. This is also a kind of, because there exists same, this is a magnet, okay, magnet, and then this is a any object. So you, even though you keep somewhat distant, what happens? If you keep distance, there will not be any force. So if you keep nearer, right? So the source and the object should be somewhat near. Then we are getting this magnetic effect. That is the this source, that is magnet and nail. This nail is moving towards the magnet. Got it? Yes. So these are the two forces which exist under the non-contact force, or it can also be called as field force. Okay, understood? Let us move to the contact force. Yes, in contact force, if you observe forces which are between two bodies, those are in contact, right? You take atomic molecular interactions. Say molecules of an atom. You take atomic molecular interactions. Say atoms are very near, right? So, and molecules are closely packed in the case of what do you say, solids, right? So if you observe, when two objects come in contact, they exert contact forces on each other. When two molecules near together like this, okay, they interact together, what happens? It experience some force on it and it also experience some force on this, like this, okay. This is a kind of contact force. That means forces which are the forces which are exist the force which exist between bodies by a short range. That is, short range means short range like atomic molecular interactions. Those are called those are called contact forces. Okay, when two objects come in contact, they exert contact forces on each other. Got it? Yes. Next, the other kind of forces. These are different forces. Okay, those two easily you can understand. Normal reaction, normal reaction, normal reaction, and tension. Okay, what are these kind of forces? Let us observe. Normal reaction. So it is also a contact force. No doubt it is also a contact force, but it is perpendicular to the surface. Okay, it is perpendicular to the surface. You take a table. Say I am taking a table like this. Okay, say this is my table. Okay, if you take this as a table, what happens? Say, this is one leg, first leg, and this is second leg, and this is third, and this is fourth. Okay, four legs. Here you observe it is this is one kind of contact force perpendicular to the surface. It is perpendicular to the surface, and it is what kind of force I said? Contact. Okay, contact force. So it is electromagnetic force. It can easily push an object. It is also an electromagnetic force also. You observe here, table presses the earth. This is the earth. Okay, this is the ground. On this ground, this is the table. Table we are observing. The table presses the earth, so normal force exerted by our legs of table on earth, normal force exerted by our legs of table, right? Normal force means perpendicular force. So this table is exerting some force on the earth, right? So what happens? Normal force, whatever the normal force, which is normal force exerted by our legs of table on earth, right? This force, these legs are also exerting some force on earth, right? Table press, actually table is pressing the earth, if you say. But when you say normal means that is perpendicular to the surface. So which are perpendicular to the surface? This is the surface, right? So legs are always perpendicular to the earth, right? So here there exists a normal force. Wherever the surface and the object is exerting, object is standing, and it is normal to the surface, then if these two are perpendicular, we can say there exists a normal force. Understood? Yes, very good. So here, next we go to the tension force. What kind of force is tension? You observe the tension, right? Tension. When I talk about tension, it is a string or thread you can take, right? String or spring also you can take, right? If you take a string, tension in a string is a what kind of force if you observe? Say, when a string is pulled, if you pull a string, what happens? If a less string is not pulled, tension in it is zero, right? If say a mossless, very light string I am taking, okay? If it is not pulled, just I kept like this, the thread will be like this, no? If it is not pulled, then is there any tension here? No, okay? There is no tension, okay? A string suspected, say I am taking a string. I am taking, this is some rigid support for a hook. I am hanging this thread, okay? Tightly I am hanging. So here also there is one hook. This end there is one hook, and this end there is one hook. Okay, I am tightening this thread like this. Yes. Okay. So the string is suspended by a, here these are called rigid supports, right? Hooks. Rigid means this, so that it, the rigid body which makes this thread not to move. Rigid means there is no reaction in on that body, even though anything comes and press it. Okay. So generally the children, they are not listening, or they are not doing any kind of work. So they can be called as rigid bodies. Okay. Rigid children, like that. Okay. Rigid support pulled by a surface, pulled by a surface F. You observe here, this is the rigid support. Yes, rigid support. So if you make the string with the rigid supports, it is experiencing some kind of force or it is experiencing tension force. Yes, there will be a tension in the string, right? So string can be, no doubt we know a string, this is a string, right? It consists of small segments, right? Small segments. So what happens due to electromagnetic nature, these two are going to attract each other, right? Attract each other. So the attraction force between the segments is equal and opposite. The attraction force between the segments is equal and opposite. What is this law? The force, equal forces acts in opposite direction, right? In opposite due to Newton's third law. Okay, we will study these also. Newton's third law. It can only pull a object. Because of this, it can only pull an object. It won't push. Okay. So in some cases, you can observe only pull or push happens, right? Only pull or push happens. Say, you observe any kind of like doors. When you open a door, they may it has been it has been written on the board like pull, right? Push, inside push, pull, like that, outside pull, like that, right? So that means here only one kind of action takes place in the case of this tension. Understood? Yes. Let us move to the next part. So we observe what are the different types of forces, what forces can do, what a force can do, okay, and how a force experiences, okay, and force definition, all the things we covered in this. Now we are going to see Newton's laws of motion, for which Newton is the unit. Yes, very good. For force, Newton is the unit. That too, SI unit of motion, SI unit of force, right? SI unit or MKS unit of force is Newton. What about CGS unit? CGS unit is dyne. Yes. FPS unit is pound. Very good. Next, first law of motion. What is first law of motion? If you observe the first law, say there is a table. On the table, you kept a book. Okay. Yesterday, yesterday evening, yesterday evening, you kept a book like that on the table. Okay. And then you closed the room. Okay. You closed the room. Now, next day, you are going and observing the book. So the book is on that place only and table is on the same place. There is no change in the position, right? There is no change in the position. There is no change in the shape, right? So it is at the same place, right? With respect to time. So here, yesterday, you observed the position. Yesterday, you observed the position of the book, okay? And today, the next day, the next day, you observe the position of the book. Position of the book is same, right? There is no change at all. Yes, there is no change at all. Now, if there is no change in this can be called as position with respect to time, you are saying, right? Yesterday and today. That is, the position of any object is same with respect to time. The position of the object with respect to time is same. Then the body is said to be at rest. The body is said to be at rest. Okay. So at the beginning, we observed force makes the body to change from rest to uniform motion, right? So rest definition, Now you got, what is that? Force is, sorry, rest. Rest means the position of the body does not change with respect to time. That can be called as rest. Okay. Motion, motion. What happens? You take a one toy car. Okay. A remote car you take. You are operating with remote. Okay. You are operating with remote. What happens? The toy car say, this is, let me take now 4 o'clock, 4:02. Okay. At 4:02, at 4:02 p.m., at 4:02 p.m., the position of the toy car is at A, right? The first wheel, the first wheel, the first wheel of the car. So this is the first wheel. Let me take, not this one. So this is the first wheel. First wheel of the toy car is at position A. When you operate this remote, what happens? The toy car moves to a certain distance, right? Immediately. Say at 4:03, at 4:03 p.m., I observed the position of the toy car is at B, right? So we can easily say that with respect to time, as the time goes on changing, here the position of the object is changing, whereas here the position of the object is same, right? So what is motion? What is motion? Motion is nothing but the a change of object, the, the position of the object with respect to time is changing. Change, change of position, right? Change of position with respect to time. Got it? Whereas change of position, the, here change of position takes place with respect to time. Whereas in our rest, there is no change of position. It should be at the same place, right? It should be at the same place, rest. And a rest, no change of position. No change of position with respect to time. Yes, got it? So this is the main difference between motion and rest. As the time passes, the position is same in the case of rest, whereas here the position going to change. Okay, rest and motion. These two are relative to each other. Okay, relative to each other. Those we will study later. Okay. Now, here, this first law, what it says. Here, the book on the table, right? Yesterday. But it is not changing its position. Yes. So the next day, I want to read the book. So what I do? I have to take the book, right? So that what I am doing with my hand, I am taking the book. That means I am applying muscular force, right? Muscular force on the book to take the book into my hand and to hold the book. Yes. So with some force, I am making the object to move, right? So when a body is at rest, what happens? So this body, what the book wants? The book wants to be in the same state. So it is not moving. So it will be it is in the same state. That can be called as a state. Here, the state means position. State means what? Position. Okay, position. That is state, either rest or motion. There are two states, right? In physics, we have two states, rest and motion. Okay, and yesterday it is at rest, so no one is touching. So it is in the same position. Next day, I want to read, so I took the book. With some force, I changing the position of the book, right? Yes. So I moved this book. I moved this book to here. I want to read. So I kept here. I because the at first the book is here. Okay. On the next day, what I do, I want to read because my chair is here. So I moved this book to here and I am going to read. I changed the position of the book, right, with my muscular force. So when a force is applied on the object, it can easily, this is at rest, right? Yesterday, too, when you till not touching the book, it is in a state of rest. When you apply a muscular force on the book, it tries to move, right? It changes its state. That is, it changes into motion, correct? So, how do we define this Newton's first law of motion with respect to these rest and motion? Come on, let us see. So, everybody, you know, any body you take, so it should be in the same state. Say, Sunday came. Okay, what you do, you are getting late, you wake up late, right, generally. So you are not moving for any work easily, right? So because night you are sleeping, so you will be at rest, right? So in the morning time also, that is Saturday night you are at rest. So again, Sunday morning also, you try to be in the same position, right? Right? So that is, you don't want to change your state. But when is a Monday, even though you don't want or you are not feeling well, you have to be ready for college, right? Whereas here, by some force, yeah, there is a college. I have to today. Today is a today is today there is a college, so I have to be ready for the college. Yes. So for that, why? Because of college. College is the force here, right? So college is the force. So you have to go to the college. That is, college is forcing you to ready early. Whereas Sunday, no college. That's why no force on you. So you are waking late. Okay, you wake up late and you ready late. All the things to be late. Yes, like this. So everybody continues to be right. Continues to be in the state of continues to be in the state of in the state of rest in the state of rest or of uniform motion or of uniform motion. Say, I gave the definition for rest. These are the examples for rest. I'll give uniform motion also. Uniform motion in a straight line. This is the condition. You have to observe the conditions always. In a straight line. This is keyword. In a straight line. Unless acted upon by an external force. External force. That is, you are seeing mobile on Sunday. Okay. Your mother came and you are enjoying, you are watching different things on the mobile. Okay. And your mother came and she is forcing you to take the mobile. That is, mother is the force here. So because of your mother, you want to return that mobile to mother, right? So that is your before that you are watching, right? So you have to give to your mother. So your mother kept it at rest, right? Yeah. So everybody continues to be in the state of rest or uniform motion in a straight line unless so everybody, everybody continues to be in the state of what? Either rest or uniform motion. But it should be in a straight line. When it is going to state, say rest to motion when it changes, when you apply a force. Say a cycle is moving very fast. Okay? A cycle is moving very fast. What happens when a big car comes before that? What it do? What it is going to do? The cyclist suddenly applies a brake, right? He applies brake. He applies brakes, right? So here the cycle is in motion. Yes or no? The cycle, you take the cycle is in motion. What happens? When a car comes in opposite way, so the cyclist, suddenly he apply brakes. He apply brakes. So these brakes are nothing but our force. Yes, because of brakes. So cycle is, what is the state of cycle? What is the state of cycle? Motion. Yes, state of cycle is motion. State of cycle is motion. Okay, motion. What happens when you apply a brake? What happens to the cycle? So because of motion, it converts into rest, right? Yes, motion to rest, uniform motion to rest. When he applies brakes, that is, unless, you see, unless acted, unless, when till you apply brakes, it should be in the same motion. Fast it is moving. When you apply brakes, it that means you are applying force. It changes into its state, that is rest. It comes to rest. Cycle comes to rest. This is Newton's first law of motion. Okay. So in this mainly, so this is also called as everybody say if the body is moving, it should like to move. Okay. If the body is in at rest, it is at rest only. That property of body, that is, it cannot it don't like to change its state, right? So if it is at rest, it continues to be at rest only. If it is in motion, the body tries to be in the motion only, right? So this property of a body which tries to be in the same state, which tries to be in the same state, that can be called as inertia. What is that called? Inertia. Inertia is the inability. Inability means it is not able to do that. What? Change of state. It won't do change of state. Okay. It likes to be in the same state, old state only. Okay. Yes. So inertia is the inability of a body to change its state. Inability. It does not like to change the state. Okay. So inertia is the inability of a body to change either its state of rest or uniform motion. Anything you take, if it is in motion, it should be in motion only. Understood? So if you observe, depending upon this, depending upon rest and motion and direction, we can classify the inertia into three types. Yes. What are those? Now we will study about inertia clearly. Inertia. Inertia is the inability of a body to change its state. It is the inability of a body to change its state. It never tries to change the state. Okay. Now, inertia, what I said, the body is at rest. It tries to be in the rest itself. If it is in motion, it tries to be in the motion. If it is in one direction, direction also you can consider, not only motion and rest. It is to be in the same direction. Okay. So inertia can be classified into three categories. This is I. Inertia of rest. Okay. Next, inertia of direct motion. Inertia of motion. Next, inertia of direction. Inertia of direction. Okay. What is inertia of rest? You take this. You can easily, I think you can easily state the definition by yourself, right? Yes, easily. Yes, very good. So the inertia offered by a body to change its state of rest. So the inertia offered by a body, inertia means it won't allow. Okay. It won't change its state of rest. So inertia offered, inertia offered, inertia by a body, offered by a body to change its state, to change its state of rest, to change its state of rest. Okay, this is called inertia of rest. Okay, what about inertia of motion? So how do you define inertia of motion? Inertia offered by a body to change its state of motion, right? So to change its state of uniform motion, to change its state of uniform motion. Whereas inertia of direction, this is also in the same way. The inertia offered by a body to change its direction of motion, to change its direction of motion. That can be called as inertia of direction. Got it? Inertia of rest, inertia of motion, and inertia of direction. These three. Now we observe some examples regarding to this. Okay. Let us take one example. If you take an example like a passenger sitting in a bus, what happens? When a jerk comes, what happens? What he do? When the bus stops suddenly, what it does? A passenger sitting in a bus gets a jerk, right? So whenever it suddenly stops, it suddenly in a bus, a passenger is sitting. A bus suddenly, this bus is moving. Consider the bus is moving. Okay, bus is in motion. When when the because of when a bus because of a jerk, this driver suddenly applies a brake. He stops suddenly. What happens? The bus gets a jerk when the bus starts or stops suddenly, right? It gives a jerk in the man. That is, he moves front like this, right? Like that. Yes. So a passenger sitting in a bus gets a jerk. Jerk means he suddenly shakes like something like that. Okay. Suddenly either starts or stops also. Not only starts, stops also. Okay. Yes. When these two things suddenly happens, then the passenger gets a jerk. Okay. Got it? So this is one of the example for this. Okay. When bus suddenly starts means inertia of rest. But suddenly stops means inertia of motion. Right? Next, if, if you take a bullet fired on a glass window, this is a glass window. Glass window. Okay. A bullet is fired onto a window. What happens? It makes a hole through it, right? It makes a hole through it, while a stone breaks the whole of it. If you If you take a stone, if you throw with a stone, so it totally breaks off. Yes. So why this is happening? You are with a stone, you are hitting the window, glass window. What happens? Just the glass window breaks, right? Breaks into pieces. But when a bullet, so here from a gun, the bullet is coming very fast. Yes, and it is hitting the surface of the glass, right? Due to large force, right? Speed of the bullet is very high due to this large motion, due to the large motion. So it is coming very fast. Due to its large motion, here it creates a hole. Yes, it is going to create a hole here. It cuts a clean hole through the glass. When a stone is thrown, its inertia is much lower, right? Its inertia is much lower. That's why it is going to it cut cut through glasses. Okay, but here it is the inertia here in this case because the hole through the glass it is having the bullet is coming very fast, right? So it is it inertia which inertia is much lower. Inertia is much lower in the case of a stone, right? Whereas in the case of what do you say, bullet, sorry, in the case of a bullet, the inertia is less. Okay, inertia is less, so that this is in motion, no? This is in motion. This is at rest. Okay, so what it do? It tries to move. The bullet is in motion here. The bullet is in motion. What is the property of any object? So any object, everybody should be in the same state because it is in motion. It tries to move in motion, right? So it goes very fast, right? It goes very fast and making a hole, and so it moves. And whereas this stone is at rest, right, at the beginning. So when you throw a stone is not just with a certain distance. You are applying very less. It is not moving very fast. So inertia of this is more. That's why, that's why it is. And that too, the inertia mainly depends upon the size also. Okay. If you take a bullet is small in size, whereas stone is somewhat big in size. So inertia is more here. Because of inertia more, what happens? So the stone is at rest, so it also moves and it hits it and it falls down here itself. It is not going inside the glass and making a hole inside the glass. Got it? Very good. So if you observe this example, you can observe that we can observe that the inertia of motion of the bullet, because of inertia of motion, the bullet is making a hole at the glass window. Got it? Yes. Because this is at rest and it is having a large inertia. So the glass just breaking. It is not passing through the stone is not passing like is not passing through the glass like bullet. Got it? Yes, very good. So this is about the example of inertia of motion and inertia of rest. Next video, we are going to study what is linear momentum, okay, and what is second law of motion, third law of motion. What are the important points which are related to second law and third law, okay? Advanced improvements we will study, and also what are the applications of Newton's laws of motion and free body diet. How to draw that? How to draw easy feed free body diagram. This is very important when you consider for J. Okay. Yes. Very good. Let us. And now I am closing this. Okay. Thank you.